All right, let's go over the quiz. You ready? Here we go. So here you are, you're a superhero. You weigh 60 kilograms, and you're made up of mostly water. And you jump off, and you go down 12 meters, and you land on the ground. You're a superhero. And you got a little bit warmer. Just like the lead bag when dropped, the potential energy turned into thermal energy. Well, the change in potential energy turned into a change in thermal energy. Let's figure out how I know that. All right, you do your conservation of energy equation, and you see that the change in kinetic energy plus the delta PE plus delta TE is equal to Q plus W. Let's pretend that your suit keeps all the heat in, so the Q is 0, and if it's the Earth and the U is the system, then work is 0, because nothing from the outside is causing it to fall, unless it was kicked by an alien, but that's not part of this. So, see how delta P is negative and delta TE is positive. So delta PE plus delta TE is equal to 0. So that delta PE equals delta TE. Well, the negative of delta PE is equal to negative. You see the negative. You see it. Negative delta PE is equal to positive delta TE. That's a lot of letters. Anyway, you know, just look at the math. It makes sense. All right. And the equation for delta PE is mg delta H. And the equation for delta TE is mc delta T. And here we go. Let's fill in some numbers. So, the mass is 60 kilograms. G on Earth is 9.81 newtons per kilogram. And the change in height is negative 12 meters, because he fell negative 12 meters. Okay. And mc delta T, the mass of the view, is 60 kilograms. And the C is 4140 joules per kilogram degrees Celsius. And then that's multiplied by delta T. So you do some math, and you end up with 7,063 newton meters on the left. And a newton meter is also known as a what? That's right, kids, a joule. So it's 763 joules. On the right, 60 times 4140 is 248,400 joules per degree Celsius times change in temperature. So how do you solve for delta T? I'll wait for it, just like Dora the Explorer. Yes, that's right. Divide both sides by 248,400. And you get delta T is equal to 0.02843 degrees Celsius. But let's find the significant digits. What? How many? Let's look. Well, our original numbers, we had 60 kilograms. How many significant digits is that? That's only 1. You see the square around the 6? Sure, that's 2. And everything else, what do we got? That's 3. So our answer, though, if you're going to divide or multiply, the answer has to be in the least number of significant digits. So that is here. And we'll get around this number. This is only 1 significant digit. Those 2 digits don't count. If you were to write this in scientific notation, you could also write it as 2.843 times 10 to the negative 2. So these digits are just there as placeholders. Just like this one here, the final answer is, let's round this to 1 significant digit, and it's 0.03 degrees Celsius. If I were to write that in scientific notation, it's 3 times 10 to the negative 2 degrees Celsius. So once again, if you're lost ever, just convert degrees Celsius into, you just convert your number into scientific notation, and you'll see how those zeros are placeholders. Okay? Fantastic. Let's look back at what we did. Wow, look at that. Isn't that cool? Oh, one more step. Oh, I'm going to crash. There it is. Okay, enjoy.